Hello, welcome to MMT mini project.
Myself Shriya Gosavi, my enrollment number is FS21CO070.
Myself Bhumika Bhoir, my enrollment number is FS21CO052.
Myself Karthik Save, my enrollment number is FE21CO048. Today we are going to explain motions in physics. Motions. Motions isn't the phenomena in which an object changes its position over time with respect to the surrounding. Motions is mathematically described in terms of displacement, distance, velocity, acceleration, speed, and time.
These are few types of motion. First, linear motion. Linear motion is a type of motion on straight line in one dimension. When an object travels in a straight line, it changes its position along with the time taken. An example of linear motion is an athlete running in 200-meter race. Five equations of linear motion are as follows. First, final velocity equals to initial velocity plus acceleration into time. Second, total displacement equals to initial velocity plus 1 upon 2 acceleration into time. Final velocity square equals to initial velocity square plus 2 into acceleration into total displacement. Fourth, total displacement equals to initial velocity plus final velocity upon 2 into time. Fifth, total displacement final equals to final velocity into time minus 1 upon 2 into acceleration into time square.
Periodic motion. There are three types of periodic motion. First, oscillatory motion. Second, vibratory motion. And third is circular motion. First, oscillatory motion. An oscillatory motion is a motion in which the object moves in such a way that it comes and goes from a fixed point periodically. Second, vibratory motion. A wire stretched between two fixed points, when plugged, it starts vibrating to and fro. Most of the musical instruments like guitars, guitar, violin, etc. have the strings attached to them to produce a music by creating a vibration. Third, circular motion. Circular motion is a movement of an object along the circumference of a circle or a rotation along a circular path. It can be uniform with a constant angular rate of a rotation and constant speed, or non-uniform with a changing rate of rotation. Terms related to the simple harmonic motion. First, time period. It is denoted by capital T. It is the time taken by a particle to complete one oscillation. The SI unit of period is second. Second, frequency. It is denoted by small n. Number of oscillation completed in 1 second is called as a frequency. The SI unit of the frequency is hertz. Third, amplitude. It is denoted by A. It is the maximum possible displacement of the particle from mean position. Amplitude is measured in meter. Fourth, wavelength. It is denoted by lambda. It is the distance covered in one complete oscillation. The SI unit of wavelength is meter. Fifth, phase. Phase is the completed description of the particle in simple harmonic motion. It gives position, displacement and direction of the particle at any instant phase of the particle is measured either in the terms of angle described by the reference particle or in the terms of fraction of time period.
Angular motion. The motion of a body which is about a fixed point or axis. It is said to be equal to the angle which is passed over at the axis or point by a line drawn to the body.
Uniform circular motion. When an object follows a circular path at a constant speed, the motion is called uniform circular motion. Centripetal and centrifugal force. A particle performing uniform circular motion is always acted upon by a force which is directed along the radius and towards the center of a circle. This force is known as a centripetal force. Uniform circular motion is an accelerated motion. Any body which performs uniform circular motion becomes the accelerated frame of reference. A particle which lies in a such accelerated frame of reference expression a force which is directed along the radius but away from the center of the circle. This force is known as the